have a new project here. Have a customer that has hundreds of welding machines that had been stopped being produced. I'd have to take a guess at around the 2006 to 2008 mark, roundabout. And they need a supply of drive rollers in their complex. Quite often the welding machine remote wire feeders are actually on the job being welded, and therefore subject to mistakes that can cause some pliers or something that goes down in between the wire feed motor and the case to touch the wire feed motor, which then makes the actual roller mechanism live to ground, which then when the trigger is pressed arcs the actual wire across the rollers and damages these. It's just part of the situation. Not much that they can do. They try and alleviate as best they can, but eventually these drive rollers need to be replaced due to arcing. Now my supply of these has completely dried up. I do have a supplier that may be able to talk to their drive roller manufacturers and see if we can get these made, but for now we're talking about months away. So for now I'm going to have a go at replicating one of these, seeing how successful I am. I can use the D-bit grinder with the cut-off wheel attachment which I've made to replicate the groove. I'm confident. Only thing that I'm not confident on is the hardness of the steel. So I generally only have mild steel here. I have got some 1045 on the way, but of course it is maximum diameter I've ordered in that batch is 31.75 millimeters. So problem with this is, of course, it's nearly 41 millimeters. So this is the bar that I've got at the moment. I'm thinking of making. Let's retrace a little bit. Hardness of the steel. So good thing is that these drive rollers are only going to be pushing aluminium wire, so total hardness isn't that critical, but we want to make them as durable as possible. So I'm going to be ordering in some 4140, 45 millimeters in diameter, so I can turn it down to get this correct OD, and then I'll consider whether I need to heat treat it afterwards. That's consideration, and to be honest, it's probably only a small step, so I probably will do it. In the meantime, to get one made as a proof of concept, to be able to give to my customer to see if it's actually going to work, whether I'm making them accurately enough, I'm going to make one out of mild steel because it's at least 2 weeks away, the 4140 bar that I'm going to be ordering. So I only have two sizes that's even close to this 40.9, 40.9. I can't remember, round about 41.9 or 40.9. And there's this piece of 40 mil, obviously too small. And then I've got a piece, I think it's either 60 or 65 mil, way too big. And instead of wasting a whole heap of material and my time, it's not so bad. I'm doing this in my own time, but what I'm going to do is I'm going to build this up with a TIG wire and the TIG welder. These only need to be about 10 mil in length, so I'm just going to build up this area here all the way around. Only needs to grow about 2 or 3 millimeters. Then I can machine it all back, produce the drive roller, and then I have some cherry red, which is a case hardening product. It's a powder. So what I'll do is I will, when I've completed it, to give it a bit more hardness and durability in the testing phase, I will case harden the outside of this drive roller, and then I may even consider bluing it to give it a bit of anti-rusting properties. I'm not sure whether case hardening gives you a bit of corrosion resistance, but yeah, so that's the project that I'm undertaking today. Yeah, we'll get going. Just going to fill this, just going to build this bar up here, up to this line, pre-machined line. It's just so happened to have had a bit snicked off it before. I didn't do it on purpose. What's this here for? Old sort of welder's trick with round bar. It's a hyper copper. Wrap it around a few times, put your earth clamp on the end of it, and it'll find its way to give you a earth, and you can rotate the bar without the earth being stuck on the end and then falling off all the time when you change the direction. I'm not a fan of this milling vise that came with my milling machine, so it can be a bit of a welding sort of vise now, but try not to arc up all over it if I don't have to, so it's prefer it to arc up through there. So let's just see here. Oh, that, sir, was no gas, but the gas is turned on. What happened? Ah, dear, oh dear. There's a goofball born every day. So I changed over to a water-cooled TIG torch. Not for any other particular reason other than just to give the water cooler a bit of a run. But some dummy changed all the leads over except the gas line. So I left the gas line attached to the other TIG torch. So gas was flowing, but to the wrong TIG torch. So let's try that again. A bit squirrely over where there was no gas. In a very good position there actually. Like my table's a little bit too high. I don't think I can make my stool go up any higher. Only I could find our lever to operate it. Nope, as high as she goes. Okay, so we'll do a little bit of left hand action here. Might fog up again. Certainly not as steady on this hand. got a bit of a round bar here that I've built up with a bit of TIG weld. So now we're going to machine it off. Hopefully I've filled it up enough to give me about 10 millimeters of 40.9 I think. I do have to double check that obviously when I get closer to it. So I'm just going to try and find the high spot. Using high speed steel. It's going to be a rather interrupted rough cut. So we'll start off with that, and if we want to go with a better finish when we get closer, I'll swap over to carbide. Right. So let's just try and find a high spot. One there. There we go. Start skimming it down. I can see I probably will have to add a bit more. Right, let's check what we're like on the micrometer. 40.9. What have we got there? .41.5. Okay, good. Although I don't think we're going to pick that up in 1/2 mil. Let's try it. Go back to 0. More compound. And then we'll add 1/4 mil. See how that goes. And I think I might be TIG welding some more on it. Yep, well that's about the right diameter there. So yes, didn't fill it up enough. It's a bit of a bugger. Just turning this down now to the final size. I had to go and add a bit more weld to the diameter, but now it's cutting quite nice. Does leave a nice finish. I know I keep saying it, but anyway. Right. Take a little guy at it, a little go at it. Oh geez, I'm within a 40.92 and a bit. Oh, that's close. Right, so what I might do is I might give Emery that a little bit. It's like only 0.01 of a millimetre or so. So I only need, I'm not going to see it from there, but 10 mil. It's a bit rough on this edge here still, so I might just take a little bit more off the face. Machine is rather slow in the cross-feed direction. Part of the change gear setup in this machine. So if I get a nice movement up and down the bed, it seems that the cross-feed is half the speed, which is probably how maths works out. But so it's really slow. If I speed it up so change the gears so it's nice cross, then it's too fast along the tube. So what I'm looking for here is a nice edge. And it's still a bit scummy there, so I might go in a bit more. Okay, it's quite nice. Right, just put it in. Chamfer on there. Right, I actually might file that a little bit. Just on the edge there. That feels nicer. Okay, so effectively it's got to have 3 holes in it. Now I'm going to do those 3 there on the rotary table. I'm wondering whether I should or should not bore this, but if I cut this off then it's going to be harder to put the bore hole through it. I'm wondering. But I can always drill the hole obviously in the drill press. I might just put a centre drill in there just in case. I don't want to go. And so the first one, working out the best way to do it, is always the challenge. You make your mistakes on the first one, and by the time you've done the 400th one, you've got it right. Okay, so I have decided to drill it out. It's going to make it easier for parting off. If you don't have to part all the way through the bar. I've measured the bore of this drive roller with some telescopic gauges, and it turns out it's exactly 12 millimeters. Got a 12 millimeter drill here. I know they don't necessarily drill exactly at 12 millimeters. I don't have a 12 millimeter reamer. I'll check this afterwards. Worst comes to worst, I have to take the tiniest skim with the with the boring bar. I will. It's sort of a locating hole, so it's got to be pretty good. I don't want to make it too sloppy, and obviously if it's too small it won't go on at all. So let's drill this out. at the bottom of where the pilot hole was. So that's now drilled out. Just trying to clean the hole out a little bit. Give me a more accurate chance of measuring it. Now, there's no point making a prototype if it's not going to be exactly bang on. You're just wasting your time. Because then if it doesn't work, is it because you didn't do it exactly as the original? Or was it because it just can't be done? So, trying to get my hand in here. Right, let's see what... We actually drilled a hole. What size was it? Tiny bit under 0.03. Just a little handy one. Take the sharp edges off. Okay, so I'm pushing the accuracy that I can get off this lathe. This could all end in tears. So what I'm going to do is just put a bit of blue on the inside of this hole so I can see if the tool is touching or not. So it's a nice piece, nice blue location in there, so as I bring the tool in, go in and out until it just removes the blue, and I'll know we're exactly on point. Now I can see by the camera shot here that there's no way that's going to be able to be seen, but trust me, it's happening. Okay, so I'm setting up the rotary table here. I'm just setting it so it's absolutely in centre, and then I've got to do the same thing with the vise, not the vise, it's called a chuck. The chuck sits on T-nuts, so it's going to be more of a challenge. It would have been nice if it had like a Morse taper in there, but anyway. Let's just fire this up nice and slowly. So then as I move the X and the Y axis in and out, we've got to basically stop this little needle from moving. So you go one way as best you can. And it's getting worse again, so let's go back to about there somewhere. Now I'll move the X axis, this is going to be a bit harder. I'll reach around, don't get in the way of the camera. Looks like I'm going in the right direction. Now it's getting worse. Let's go back the other way a bit. Sort of. Let's go back to the Y. Oop, wrong way. Too far. Basically got to try and get the needle to stop moving. Still too far. Depending on how accurately you want to be. That's just jiggling. I think that's good enough for what we're doing. Okay, so turn him off. Okay, so now I'm going to chuck the vise on there, find a way of indicating that. Probably, I'll work that out when I get to it. I've never done this before in real life. I've dreamt about it many times. I've seen a lot of blokes do it. Right, now I've got a little problem. Drive roller. How do I find the centre of it to work out then what the pitch circle diameter will be? So put these holes in the right place. Well, there's a certain way in which you can determine the centre. Well, this is how I know how to do it, by some maths. First of all, this is a triangle. This is what these three holes are forming. So this only works for a conventional triangle. What is the word I'm trying to come up with? It's a... these holes form an equilateral triangle. So to work out what the radius is, and then you times it by 2 to get the pitch circle diameter, but to be honest we only need the radius because that's all we have to move off centre to start drilling these holes. So you can do the old gasometer trick. So I'm trying to look at this through the camera. How about I just sneak a little view over the top? So sort of that's got to be close-ish there. So that's a close-ish guesstimate. But if you have a real good look at these holes, you can see they are a bit elongated. So we're still guessing. Luckily I have his brother who has the same bolt pattern. These holes are in much better condition. So how I'm going to go about doing it is you measure the distance, the shortest distance between the holes, which is 16.28. Type that in your calculator. And then the maximum distance between the holes. And we're looking at 25.3536. Let's try another one. Oh, that was in. You've got to try not to cock-eye your calipers. You've got to try and keep them as square, as parallel as possible. So, still, this is still not as accurate as you'd like. 25.3. So we have a total of 41.58. Now, divide that by 2 gives you the distance in between, because we've added the two, we had the outside and the inside together, so you've got two measurements. Divide that by 2. Should have 28.93. That does not look right. That's what? How did that end up with that? No way that's 28 there. What did I do wrong? Let's try that again. So you measure the longest distance across between the holes, 25.35. Plus shortest distance between the holes. You're looking at about 16.25. Let's put 16.24. Right, 41.59. Divided that by 2 because we've actually put 2 measurements in there. Equals 20.79. Now, once you know the length of one side, you divide the length of that one side by the square root of 3. So the square root of 3 is 1.7 something and a whole heap of other random numbers. So I've already have that saved in as a memory in my phone. So we'll divide that by memory recall of 1.73.205. There you go. Do it on your own calculator, you'll see that you'll get the same answer. So 12 is the radius between here and here. So let's just adjust this to 12. As near as damn it. Near enough for demonstration purposes. So radius is going to be 12 between those. As best as I can measure it, I think it's a better way of doing it than guessing. Like just without that knowledge of it should be 12. You know, I could have come up with the same answer, or I could have gone, no, it's 12.28 or something else. That's the best way that I have right now. I'm going to come up with that. Customer says it's a little bit tight, the bolt holes seem to be too far apart or a little bit too close, we can adjust it by a little bit. This is only a prototype to make sure that it's even feasible to make these things. Right, over to the milling machine. Got everything set up in the milling machine now. I've offset the x-axis by 12 millimeters, which is going to give us the positioning for the drill holes. Now, I've positioned the job and this jaw here, where the jaws are, so that I can actually drill through down into the slot where the jaws slide. Otherwise there's a risk of hitting the actual chuck itself. So that should work out well. The only problem I have though is that on the side of the rotary table itself, it's a weird number that it's landed on, instead of being like an easy one to work out like 0 or 60 or 120. So I've ended up on 280 degrees. So what I need to do is add 120 every time, only 2 more times to get our triangle. So that's just something I've got to watch out for and don't muck up. A little bit more speed. Okay. Let's take that one out. And next in is, closest I can get to fit, is a number 12 number drill. Alright, that's through. Depth is smidgen over 4 millimeters. So I've reset my indicator, DRO, what do you want to call it, and we will have a crack at drilling that down 4 millimeters. I should be using the hammer really, shouldn't I? Idiot. And that's it. There we are. Okay, so now I'll change back to our little center drill. And we'll go 120 degrees. So if we were at 280 minus 120, we need to be 160. Coming up now. All right, 160. Wrong way. Forwards would be nice. I probably should be using a bigger center drill. Let's change that center drill out. I think. get our 0 first. Right. Down 4 millimeters. Doesn't like starting that drill bit for some reason. Once it's going, it's good. There we are. It's 2 done. Okay, now I've got my direction right. Let's make that 120 minus 160 minus 120 is 40. Bring up to 0. 40. Lock everything down. Okay, last little bit, zero out our little DRO. Down to 4 millimeters. Back you off a bit of speed. Right. So if everything was done right, it should actually match the others. Let's quickly see. Take this out of here now. So there he is there. Now let's see. Put them together. And the holes line up as good as I can see. Okay. Just do a little bit of a deburring. And next process is going to be put the groove in it. This is where the rubber hits the road. So where the groove goes in, if these aren't identical, they should be real close. I'm going to measure from the back side, because that's the mounting plate that this bolts up to. So this is the critical measurement from here to the centre of the groove. I'll do the same from there to the centre of the groove. What I've got to do now is make a little mandrel up to suit that, so that I can put a bolt and a washer in there, so I can hold this to be able to turn it in the D-bit grinder. Right, over at the D-bit grinder, or universal grinder. This is a pretty critical stage here, because if I muff this, then it's scrap time. And put a few minutes in doing this, that's for sure. So I'm just going to do a couple test grinds in different places, and you probably can't see, but there's one right there. I'm just going to touch off in a few different places and make sure as best I can that this groove is coming along in the centre. I have calculated it with all the little dials and bits and pieces on here. This isn't really a precision instrument. I'm sure the machine that it was cloned off, I think it was a Deckel, no doubt was a precision instrument, but just gonna see. So time to power up, touch it off and see what it looks like. Yeah, that doesn't look good in the centre there. Looks like I've got to come which way do I have to go? That's the whole idea. So it's a little bit close to this edge, so I need to come this way. Touch off there. Pretty hard. What I'm doing is I've got this caliper set to well, not roughly, to exactly half. Now I'm just seeing where the groove is, putting the same angle, because I do have to bend it over or angle it a little bit just to pick up that edge. So I can see that looks like it's in the centre of that one, and it's not quite on that one. So still got to go try that. centre. It's coming right. A little bit more, I think. Make sure that's very close centre. Close. Be sure that's going to be it. I'll just put a stripe all the way around it. Gonna need some earmuffs. Okay, so I'll continue on. Now the only difference, well not difference, but the groove in this guy is quite wide. I don't know whether it's worn, but the only way I can get a bigger groove, two ways. I can go up to the next size cut-off wheel, but that's going to be 1.6, which I believe will be way too big. It's hard to judge. Another way to do it would be to change the angle on here so that, let's zoom out a bit, other zoom, change the angle so instead of the wheel sitting square with the cut-off wheel, it actually is on a bit of an angle. Obviously I'm exaggerating it, but with that sort of angle like that, it's actually going to slice down through and cut almost sort of like, instead of cutting in one place on the wheel, it's going to be cutting on one side on the entry and one side on the exit if it was on an angle. So, yeah, on an angle like that. That's something I can do if this works. You know, there's always tune-ups that can be made. I might need to have it on a 3-degree angle to get that wheel to give that type of groove. But for now I'll carry on in this manner. Now I do have to measure make sure that the wire, which I do have a piece around here somewhere, I don't know what I did with it. This is in here. This is our 1.2 wire. That's got to fit in there. Okay, Sergeant. And what did I do with her? Oh, I'm so good at fucking losing shit, Jesus. I'm going to put the mask on. Because this stuff is not very nice. Anyway, trying to quench it. Right, so there's our original roller. Here's the one I've just finished. You can see the grooves. Not sure how close this camera will focus in, even if it's close to focused at all. Now, a bit of the motley colour comes from the case hardening. So because I have made an assumption that these rollers need to be quite hard, I've case hardened this mild steel. Now, I'm not so sure how hard it had to be, because I've just hit both of these with a file, and this case hardened one slid off the file way more readily than this one. So anyway, we'll put it out into the field, let the customer test it, and then hopefully we're onto something that we can make and keep some welding machines that have passed their due date, and the sell by date or whatever, past their prime, keep them going.